Okay, for question number 1, it's asking us which set of data is qualitative. So choice 1 would be the answer, because if you looked at the other 3 choices, everything else can be analyzed using numbers, whereas choice 1 is more just a characteristic, someone's favorite color. Number 2, we're being given information about mean hours of work and the standard deviation of those hours based on employees working 2 different weeks. The manager concluded that there was more variation in the number of hours worked for week 2 than for week 1. So what was the manager's conclusion? So in week 1, they give us a mean of 35 with a standard deviation of 1.5, and in week 2, the mean was 40 with a standard deviation of 2. So week 1 had a smaller standard deviation than week 2, whereas the manager was telling us that he thought or she thought there was more variation in the number of hours worked in week 2 than week 1. So the manager was saying that week 2 had more variation, which does go ahead with our data because the standard deviation is larger in week 2. So I would definitely say valid, get rid of choices 3 and 4. And the reason it's choice 2 is it's valid because the standard deviation is greater than the standard deviation for week 1 as opposed to week 2. It has nothing to do with the mean when we talk about deviation. For question number 3, we're looking at quiz scores from 2 semesters of an algebra class. So just to kind of give us the information that they're asking, I gave the stat 1 variable statistics readout from the calculator after I typed each of these into L1 separately. This was the readout for semester 1, this was the readout for semester 2. And they're asking which statement is correct. Choice 3 is the answer. Choice 3 said the mean score for semester 2 is greater than the mean score for semester 1. So if we look at the mean score, here's semester 2, 87.5, and that would be larger than the mean from semester 1, which is only 86.3 repeating. If you took a look at the other 3 choices and compared, they talk about interquartile range and median scores, and if you look at the data, all 3 of these are incorrect. Question 4 is giving us a few different box plots and asking us to determine which destination has a median temperature above 80 degrees and the smallest interquartile range. So we're really looking at 2 things here. So first I might look, all right, well, which one has a median above 80? So the median is always going to be the line that's drawn through the box, not the outer edges. So I can see Ocean Beach, the median here, if I look down, it's a little bit over 75, but it's definitely not above 80. Whispering Palms here has a median above 80. So Whispering Palms is a possibility. Then we look at Serene Shores. If I look down here, that's slightly below 80, so that would not be an option. But we can see that Pelican Beach is above 80 at around 84, 85. So now I have to see out of these 2 options which one has the smaller interquartile range. So interquartile range is when you take your Q3 and you subtract your Q1, otherwise known as your upper quartile minus your lower quartile. And on the box and whisker plots, when you draw your box plot, just for a general box plot here, this represents Q1, the first part that starts your box, and this represents Q3. So if the box is bigger, it'll have a bigger interquartile range, and the smaller the box, the smaller the interquartile range. So Pelican Beach definitely has a smaller interquartile range than Whispering Palms. So the answer here was choice 4. For question 5, we were given data from students in a class that was reported, and we're asked for the cumulative frequency histogram that would represent this data. So what we did was we took all the intervals and the frequencies of those intervals, and we took a look at the cumulative intervals and the cumulative frequencies once we made the original interval and frequency. There were a couple different choices here. So once they say cumulative frequency, I know that I'm not looking at graphs 1 or 2, because these intervals are only going up by intervals of 10. They're not adding from the beginning each time, which would be more cumulative. So between graphs 3 and 4, now I just need to see which one has my cumulative numbers, my 2, 8, 15, 19, and 20. And if you take a look, this would be graph 4, not graph 3.
Okay, so question number 6 is asking us when data is skewed to the right. So if our data was skewed to the right, we would have something like this. And that means that we have our outlier somewhere on the right-hand side, and most of our data is on our left-hand side. So if we look at this, majority of the data is not to the right, so we can cross off 1 and 2. And now we want to see how our mean is affected. So our mean is actually going to be pulled to the right more because of that outlier pulling it. So our mean is actually going to be larger than our median because our outlier is affecting it. So our choice is 3. For number 7, they're conducting a survey for 2,000 students to estimate the average number of hours they spend studying each week. Every 10th student entering the library was surveyed. The data showed the mean number of hours that students spent studying was 15.7 per week. Which characteristic of the survey could create bias in the results? So bias means it tells us something that could maybe cause our survey to go one way or the other. So our answer here would be choice 1. Surveying students who entered the library. If you're entering the library, you're most likely going to be studying more than someone who is maybe on a football field or in a general place like the cafeteria. So that would create our bias. So question number 8 is asking us which situation is an example of bivariate data. So bivariate data means that we have 2 different variables. So choice number 2 is our answer because we're talking about the number of times she goes to Starbucks a week and the amount of money. So that's 2 different things that we're talking about. So our answer would be choice 2. Number 9 is which measure of central tendency is most affected by an outlier. When we have an outlier, the one that's mostly going to affect is our mean, because when we average in either a very high number or very low number that's different than most of our numbers, it's going to either skew our data to the right or to the left. So our answer is 1. So for question 10, they're giving us a function, and they said, what is the average rate of change over the interval of 1 to 5? So first we need to evaluate what our values are for 1 and 5. So if we substitute 1 into our first equation, because 1 is less than 2, we would find out that our y value is 4. For 5, we would then plug into our second equation, negative 6x plus 10, because 5 is greater than or equal to 2. So if you plug in 5, you would get an answer of negative 20 from using our second equation. When they ask us our average rate of change, we know that is our change of y's over our change of x. So we would do negative 20 minus 4 over 5 minus 1. We would get an answer of negative 24 over 4, which is also negative 6. So your answer was choice 2. For question 11, they tell us that Jen is selling lemonade for $1.50 per cup. She begins the day with $4.50 in change. The amount of money, represented by M, she has as a function of the number of cups she sells is M equals 1.5C plus 4.50. They want to know which of the following would be an appropriate domain for this function. So our domain is our x values. In this case, we're talking about how many cups. So if we're selling cups, we wouldn't have a negative amount of cups. We wouldn't be able to sell half a cup. So number 2 would not be our answer. Neither would 3. So our choice would be 4 because we would be selling whole number cups. For number 12, they want to know the sum of 2 consecutive odd integers is at least 16. Which of the following inequalities would model this statement? So for this one, if we had let n equal our first odd number, if we wanted to get to our second odd number, n plus 2 would equal our second consecutive odd They then tell us that we want this to be at least 16. So if we're talking about at least 16, that would be greater than or equal to 16. So if we added both of these, n plus 2, we want that to be greater than or equal to 16. So that would be choice number 3.
Okay, for question 13, we were given data on an annual deer population in a forest, and the following information was found. The lower quartile, otherwise known as Q1, is 12. The second quartile, otherwise known as your median, is 15. Upper quartile, otherwise known as Q3, is 22. The minimum is 8, and the maximum is 27. We were asked to use the number line to construct a box and whisker plot to display the data. So I just went ahead and labeled my interval on my number line. I just counted by 2s, but I did go up by 1s. I just only labeled all the even numbers to save myself a minute here. All right, my minimum value is 8. So at 8, I'm going to draw myself a little line, and at my maximum, which is 27, which would be here between 26 and 28, I'm going to draw myself a little line. Then the box is constructed by your Q1 and Q3. So at 12, that's where I'm starting the box. And at 22 is where we would end the box. So again, we can connect those lines to form our box. And we can draw the whiskers out down to our max and mins. Again, trying your best to be a little neat. And then the last thing I have left to do here is just to draw in my median, which would be 15, which would be right over my 15. For number 14, we were given test scores from 18 students, and we were asked to complete the frequency table. So we would take some time, go through your list. 51 to 60, we had a tally of 2, so that's our frequency. Every score between 61 and 70, we had a total of 2. 71 to 80, we had a total of 4. 81 to 90, there was a total of 6. And 91 to 100, there was a total of 4. And what I would advise you doing is, as you're filling out this frequency table, to just be crossing off the scores as you count them, so that you are accurately filling in your frequency. Then you are asked to draw and label a frequency histogram. So the labeling comes from giving yourself a title. This would just be called a frequency histogram, where the frequency is acting as our y-axis and the interval is on our x-axis. I went up by 1s on the y-axis. You needed a break since we're not starting our intervals until 51, and since my origin is at starting at 0, I need to give myself a little bit of a break here in the graph, which you can see we drew in, to show that then we're starting at the number 51. I skipped by 2s. You can see that there's a little bit of my graph left, so we could have skipped over by 3 also, and then I shaded it. So 51 to 60 and 61 to 70 both had frequencies of 2. 71 to 80 went up to 4. 81 to 90 went up to 6, and 91 to 100 also went up to 4. Okay, question 15, we were given data about the number of brothers and sisters that students had in their families and asked to create a dot plot to display the data. So I took a minute just to start the dot plot. So there were 2 students that had 0 brothers and sisters, 3 students that had 1 sibling, 5 students that had 2, 3 that had 3, and 2 that had 4. So after completing your dot plot, which again is just you're giving yourself a dot for each piece of data, and when you count up the dots, that should be your total frequency for that number. We're asked to describe the shape of the distribution of our data. So is it skewed right? Is it skewed left? Is it symmetric? So this data would definitely be symmetric. We can see that it falls evenly on either side of the middle. We have 2 dots on the outside, then it turns into 3 and 3, and then in the middle we have 5. So that would definitely show us symmetry. Then a student in Mr. Smith's class thinks that both the mean and the median would both be used to best describe this data shown in the dot plot. Do we agree or disagree and justify? So I would say I agree. And the reason is that since the data is symmetric, the mean is actually going to be equal to the median. So since the data symmetric. The mean is equal to the median. And they would both be 2. Is equal to median. And if you weren't sure, you could have actually typed in all of your data into your lists and looked, and you would have been given back in the calculator that the mean was 2 and so was the median. Okay, and the last question on this test, number 16, gave us a smaller rectangle centered within a larger rectangle, and we were told that the area, the shaded area, is created based on that shape. So the dimensions of both rectangles are given. So our larger rectangle has dimensions of 2x plus 7 and x plus 3, and our smaller rectangle is x plus 3 and x minus 5. We were asked to find the area of the shaded region as a trinomial in terms of x, and then to explain how we arrived at our answer. So just in general, how we would find the area of this shaded region, I would start out by first finding the area of the larger rectangle, which we can find by taking 2x plus 7 times x plus 3. And then I would need to find the area of the smaller rectangle, which I could find by taking x plus 3 times x minus 5. If I subtract what I just drew in red away from what we had in green, I'll be left with what's in the shaded area in blue. So let's take our 2x plus 7 times x plus 3, and then we're going to subtract from that the product of x plus 3 times x minus 5. So you could use the box method or the distributive method. I'm going to choose to distribute. So we get 2x squared plus 6x plus 7x plus 21 minus, now when I subtract these, I have to remember that I need the parentheses until I'm done simplifying and distributing that negative sign. So right now I have x squared minus 5x plus 3x minus 15. I can combine some like terms here. So I have 2x squared plus 13x plus 21 minus, and again I have some like terms on this side, x squared minus 2x minus 15. Now I'm going to subtract, distribute this minus sign into a trinomial on my right. So I have 2x squared plus 13x plus 21 minus x squared plus 2x plus 15, and I'm going to combine like terms, so I should be left with 1x squared plus 15x plus 36. So that is the trinomial in simplest form that is representing the area of my shaded region. Now I ran out of room a little bit up there, but I'm just going to explain now in words. So I would just be saying here, again, this is still from the top, I found the area. We'll say I found the shaded area by subtracting the area of the smaller rectangle from the larger rectangle. Okay, now the second part said that the area of the shaded region can be written as the product of this binomial, x plus 3, and what other binomial. So I'm just going to rewrite the area that we got for our shaded region. And they told me that it's going to be equal to the product of x plus 3 times some other binomial. So what they're really asking me to do here is factor. So if we were just factoring this trinomial, we'd be asking ourselves what multiplies to 36 while also adding to 15. And the nice thing is that we have one of the numbers already. We have 3. So what you're really answering is 3 times what gives you 36, and 3 plus what gives you 15. And that number is going to be 12. So x plus 12 is the other binomial that would multiply with x plus 3 to give you that trinomial of the shaded area. And all you needed to do there was just to show that work to support your answer, which we showed by factoring.